Hi, my name is Curtis Lowe, and I helped build this game called Leaving Planet Earth. It's about the Earth is basically dying, and you have to get to NASA, journey to NASA, build a rocket ship, and go to a new planet in order to survive. So that's what this game is about for my CIT 260 class. And building this program or this game, we try to use the 7 steps in the development process, which is first define what we want the program to do, design it, which is kind of planning it out ahead of time before we start getting into the code and everything, and then developing is doing all the code, writing all the code out, and testing is the 4th step, is to make sure all the code is actually working, and deploy it out, basically publish your game, you could say, and then get feedback on it. Have people try it out, test it out for themselves, and get feedback on it so you know what's working, what's not working, what could be improved, what's working, and what's perfect. And then from there, the last step is to iterate or go back through and just kind of make those changes. So we've been trying to do that throughout this whole semester as we've created our program. So I just wanted to show you a few things that we've done in the second half of the semester here. We've been using static class variables and class non-static or instance variables as well. You can see here in the game control Java game control file, we have quite a few different static variables, such as here public static player, create player. Again here, new game, save game. We have a lot here, and the Leaving Planet Earth are kind of a master file, you could say, for the game, player, and whatnot. We use the static variables here because the static variable means that it's kind of constant. It doesn't just go away with one use. It's a variable that we use throughout different functions within the program. A non-static variable or an instance variable would be a variable that's created for just one instance or one use in one particular function, and once that function is done with that variable, we're done with that variable as well. And that's the difference between the static and non-static variables. And so you can see here that this is a static variable player here with a static function to create the player. That's one example of the static function here. We've also started to use more lists in our game. I have an example here up on the GitHub when we created our actors. For this game, we didn't really have a whole lot of actors or characters that the player interacts with. We just have 2. We have the rocket scientist George here, and Builder Bob, not to be confused with Bob the Builder, here. And their main purpose is George is supposed to help you. He's a scientist at NASA, where you go to build your rocket ship. He's there to make sure you can build your rocket ship correctly, which is probably really important when you're, doing interplanetary travel. Builder Bob is, before you get to NASA, he's there to help you understand how to build a shelter so you can survive the journey to NASA. And these 2 actors were created in an enum style list. Meaning that they're unchangeable and they're very much static. That rocket scientist George is always going to be rocket scientist George at NASA to help you out with the rocket ship. Same thing with Builder Bob. He's static. He never changes. An array lists and arrays are more for like inventory lists. When you have a longer list of different variables, for our inventory, it would include stuff like sticks and tarps and hammers and stuff like that to build shelters, as well as fruit and vegetable and water for food and water for the player to survive the journey to NASA. And that would be put in an array list because those variables can change, like the order of the variables can change, as well as the number of the variables. For example, well, obviously once the player, if he has 5 fruit and he eats 1 fruit, they obviously have 4 fruit left, so that changes. That's why those aren't an enum list. So you can see here an example of an enum list there, and we also have a list here for the fruit and vegetables and water. This is the food menu that we've made as well. So you can see the different types of lists that we've used in this game. So another big thing that we've done the second half of the semester is running custom runtime errors in the program. I went ahead and made different exception programs or functions. I'll show you the game control exception. This is just this is the program that catches and throws the errors, so that when an error is had in the game, it doesn't just give you some unintelligible response so that the player just doesn't understand what the heck just happened. We wanted to make sure that the player gets an error message that makes sense, that they know what happened, what went wrong, and what they can do to fix it. So like I said, this is the game control exception, so this works with the game control program here. And here you can see here we have the public static void save game. This throws the game control exception, or this function that I just showed you before, and as it tries to go through the function here, if there's an error, it's going to catch the error and then throw the message. So I had another one. Here's another one for leaving planet Earth, and we're going to get to a little bit more about this in a second, about writing data out to an external file. But you can see the error message here is error closing files. When it catches the error, it's going to print this out to the player so they know exactly what happened, instead of just giving some random error code with a bunch of numbers and letters that the player won't understand. It's important that we did this so that the player understands exactly what went wrong, and so that they can hopefully better understand how to fix it. So, like I said, another thing we did, like I just mentioned, another thing we did this second half of the semester is start to save data to an external file. That can be done through a byte stream class and a character stream class. The character stream class is more for like letters and stuff like that, such as the player's name. A byte stream class is more for data and for numbers, stuff like that, such as how much fruit is in the inventory, how many sticks and tarps they have to build shelters in inventory, stuff like that. So you can see here again in the leaving planet Earth.java file I have up, you can see the different functions and code that we used to write character data to an external file. So here we have quite a bit of it right here. We have the new buffered reader. The out file means that it's going to be saved to an external file. And then here we have, so this first part here just opens the character stream files so that the user can put in input and have output and everything. And so that actually opens up the stream, right? And then the second part here opens the log file, or in other words, accesses the file where everything's going to be saved to. In this case, it's just log.txt. And then it starts running through the program. So you can see how that works. And it's always important as well that it's closed. Otherwise, the game's going to have problems if that stream that's being used to write data to that external file isn't being closed. And you can see we have that catch for that error here. And all of this here is to actually close the stream so that we avoid those problems. And again, if it doesn't work, we have this error that we've implemented using the catch and throw. So that's a lot of the work that we've done in the second half of the semester here, just on NetBeans as well is here on GitHub. And we've learned a lot. It's definitely been a struggle, but we've enjoyed learning a lot about Java in this class. So thank you.